Hi guys, this is Mrs. Lyons. The next unit that we're going to talk about is chemical reactions. And before we can start looking at how compounds and elements combine to make new compounds and elements, we have to do a couple of things. The first of those is we have to talk about how we write a chemical equation and what the parts of a chemical equation are. So that's what this first video is going to be about. So the parts of a chemical equation that we need to be familiar with are, the main thing we always want to look for is this arrow right here. This arrow is kind of a divider in our chemical equation, okay? And what it divides the starting materials for the reaction, okay? In other words, we have a name for these. We call them the reactants. So anything on the left side of the arrow is a reactant, and each individual element or compound is divided by a plus sign. Okay, so that means that NaCl is one thing, AgNO3 is another thing. Those two things are going to combine. The arrow you can read it as yields, produces, forms, makes. So we're going to say NaCl plus AgNO3 make. And then on the other side of the arrow, we have AgCl as one thing, NaNO3 is a second. These things on the right side of the arrow are called the products. Okay. And then there's some other things in here that you want to be able to know what they mean. These little abbreviations in parentheses. We've got AQ, AQ. Here we have S and AQ. Okay, these little abbreviations tell us the states of matter that the substances are in. So this is pretty easy. S stands for solid. L stands for liquid. G is gas. And then AQ is aqueous. And what that means is dissolved in water. As we move on, it's important for us to be able to write a chemical equation correctly. Okay, so if you read in words a chemical equation, the word and, or is mixed with, or reacts with, when we read those words, what we're going to write down in our chemical equation is the plus sign. If we read the word yield, produces, or forms, that's going to indicate where the arrow in our chemical equation goes. Another thing that you need to be familiar with, and we haven't talked about this before, but there are 7 elements. And when we find those elements naturally occurring in nature, they occur as what we call diatomic elements. Okay, and diatomic means 2 atoms together. That's the way they occur naturally. There are 7 of these, okay? And I have a silly way of remembering them, and I'll write them down first. So hydrogen is 1, oxygen, bromine, fluorine, iodine, nitrogen, and chlorine. Okay, so these are the 7 diatomic elements. So whenever you see chlorine reacted with something, you have to remember that it's Cl2. Now, how do I remember this? I made it into a silly name. If you read it, it says Haber-Finkel. Haber-Finkel. So if you remember Haber-Finkel, you can remember the 7 diatomic elements. You'll need to remember that. Okay, so this slide is just a summary of all of the things that these abbreviations you might see. Okay, the ones that we are going to pay special attention to, I'm going to put a star by. The ones that you absolutely, totally need to know. Now these, you know what, it wouldn't hurt. If you see an arrow formed pushing down, it means a precipitate is formed. We have to define a precipitate. If you see an arrow up, it means that gas is formed. So these are useful things. This arrow. We'll get into equilibrium later where we have a double arrow. Delta, or the word heat, means that we added heat. We won't talk much about pressure. Something over the equation, a temperature over the equation tells us what temperature it is at. And we're not really going to talk too much about catalysts, but if you saw an element over the arrow, it means it's a catalyst, and then electrolysis, which we will not talk about much. So let's get into how we write these equations from words. All right, so here we have a sentence. Aluminum metal is reacted with aqueous hydrochloric acid to form solid aluminum chloride and hydrogen gas. So we need to put this into a chemical equation. Okay, so first we need to underline the things that are involved. So we've got aluminum, and then we've got hydrochloric acid to form aluminum chloride and hydrogen gas. Okay, here's some important things. Is reacted, that means that's plus with aqueous hydrochloric. To form, that's where our arrow is going to go. Aluminum chloride and, okay, so let's start taking this apart. Aluminum metal, we have to know the symbol for aluminum is Al. The word metal tells us what state it's in. We know that at room temperature, aluminum is a solid. Is reacted with, we said that's the plus sign. The next thing is aqueous hydrochloric acid. We haven't named acids, so I'm going to tell you that hydrochloric acid is HCl. And if you ever come across anything that we haven't named, like an acid, just ask and I'll give you the formula. It says it's aqueous, so AQ, all right. To form, this is where our arrow goes, solid aluminum chloride. Now, this is where we refer back to our former unit. Aluminum chloride, we know, is AlCl. This is an ionic compound. Remember, when it's ionic, you can't just write the letters down. You have to think that aluminum has a +3 charge, chlorine has a -1 charge. If we crisscross these, we get AlCl3. And notice it says it's solid. And then we form hydrogen gas. Now, am I going to write this just this way? No, I'm not, because hydrogen is one of the Haber-Finkel elements. It means it's a diatomic when it's formed naturally, and it's a gas. So this would be a complete, written in chemistry terms, chemical equation. All right, let's try a second example. The sentence says aqueous copper nitrate and aqueous sodium hydroxide form solid copper 2 hydroxide and aqueous sodium nitrate. Hold on. Okay, you might notice that this slide is a little bit different. I changed it. I didn't like the original compounds that were in here, so we're going to back up and look at this slide again. We're writing equations, so we're going to pick apart the parts. We've got aqueous magnesium nitrate, and, so we know this is our plus sign, aqueous sodium hydroxide form, okay, so form is where our arrow is, solid magnesium hydroxide and aqueous sodium nitrate. So we have 4 things in this equation again. And we have to think about this. We've got to go back and use our rules for writing ionic compounds. Okay, magnesium nitrate. We know magnesium is an Mg. We also know it's a +2 ion. Nitrate, if you remember, nitrate is a polyatomic ion, so you're going to have to look at your polyatomic ion chart. If you do, you should find it's NO3 with a -1 charge. Okay, if we crisscross our charges, remember the charge goes down outside of the parentheses, we end up with Mg, NO3, 2, and it says it's aqueous, so we're going to put the AQ here. Plus, we have sodium hydroxide. So we know sodium is Na +1. Hydroxide is a polyatomic ion. It's on your polyatomic ion chart, -1 charge. Since our charges are the same, they cancel out. So we just have NaOH, and it tells us it's also aqueous. Then we have forms, so that's our arrow. Solid magnesium hydroxide. Okay, so now we get magnesium, Mg, which is +2, OH, -1. All right, remember we crisscross outside of the parentheses, so we get MgO3. tells us that it's solid, plus, what's the last thing? Sodium nitrate. Sodium is Na plus 1. Nitrate is NO3 minus 1. The charges are the same, so they cancel each other out. NaNO3, and this is aqueous. Okay, so there we have our chemical equation. We will do some more practice when I see you in class, but that is it for now.